Hello everyone and welcome back to the Lisa Burke Show. Wonderful to have you with us always. And today we're going to talk about something that every single one of us does without thinking dozens of times a day. We turn on a tap, we fill a glass, we make a cup of tea, many teas in my case, and we assume the water coming out is simply water. But it's not quite that simple. Our water carries traces of everything that we put into it, from the environment around us, from medication we take to the cosmetics we wear, flame retardants in our sofas. Some of it is monitored and controlled. Some of it we're only just beginning to learn about and detect. And water, of course, flows. It does not stop at a border, a political border, a geographical border. And so to help us understand what's actually in our water, why it matters and what we can realistically do about it, I'm joined by one of Europe's leading voices in this field. My guest today is Professor Emma Schymanski, Head of Environmental Cheminformatics at the Luxembourg Centre for Systems Biomedicine at the University of Luxembourg and an FNR ATTRACT Fellow. She has a double degree in chemistry and environmental engineering from the University of Western Australia in Perth, completed her PhD at UFZ Leipzig and did her postdoc at EWAG, which is the Swiss Federal Aquatic Institute in Switzerland. She served as special advisor to the Rector for Open Science and Research Data Management. Her research combines cheminformatics with high-resolution mass spectrometry. Stay with me here. We won't go too much into mass spectrometry in this conversation, but it's used to identify the unknown chemicals which are hiding in the complex samples of water, which she studies. And then she connects them to the environmental causes of their whereabouts and potentially disease also. She's a driving force behind several major open science initiatives, including PubChem Lite for Exposomics, the Norman Suspect List Exchange, MassBank, MetFrag, PatRune, all aimed at helping scientists around the world share data and identify contaminants faster. And so in this episode, we're going to follow the journey of water itself, where it comes from, what it picks up along the way, how it's cleaned, what's left behind after treatment. We're going to talk about the chemicals scientists already know how to look for and the ones we don't even know exist yet in water. We're going to separate public perception, our perception, from the scientific reality, particularly around the debate of tap water versus bottled water. And of course, we'll have some practical tips along the way, what we can actually do to reduce our own exposure without falling into panic or false certainties. So, Emma, you do such great work, and it's all about water, something so precious to us, so actually important to us, and many people say it could be the cause of future wars, but we're not going to talk about that. We're just going to talk about, we're going to talk about water. So let's start with the water cycle. Can you talk us through the water cycle from rainwater to the rivers to groundwater to the glass in our hand?
Sure. Thanks for the wonderful introduction. And yes, you're perfectly right. It's a water cycle, and especially growing up in a very water-restricted country, it's been amazing to see what's happening with Luxembourg the last few weeks. I think all of us are beginning to appreciate how much the rain actually brings us day to day. So yes, the water cycle, I grew up on a coastal area, so you could always see the front of clouds coming from the ocean and bringing in the rain that would hopefully relieve our heat, although usually in summer it never did, which is kind of what we're experiencing now. So you'll see during the heat you get a lot of evaporation. This will eventually create clouds, and this will come down as rainfall. And then if we have like the alpine areas, of course, we have glaciers that will melt in the warmth as well. These will form the so-called source areas where the water comes from. This then, as you so rightly mentioned, flows through a lot of different geographical and physical boundaries irrespective. We've actually viewed a lot of different source areas in Europe, so it's very fascinating to see where this goes. And this can come through surface waters. It can also sink into the ground and come into the groundwater. We can, in Luxembourg, we have, for instance, the lake Esch, the Thur, is part of our drinking water, about 50%, and we also have 50% from groundwater. And this groundwater can be recharged from the surface water or from the rain. And then, of course, it's abstracted from either the groundwater or the lake, and then it comes into drinking water treatment. So drinking water is, of course, treated before it comes into our taps. And then this is distributed to the tap. And then, yes, we very conveniently turn it on and have a great glass of water.
And we are lucky. Of course, we should
lucky.
also mention that in many parts of the world, people are not that lucky at all. Now, you mentioned, again, you grew up in a very dry area, Western Australia, Perth, and saline area as well. You came to Europe to do many years of further studies and you work here now. You said to me before that when you came to Europe, there were still patches of virgin water untouched by human sources. Is that the case today?
I would say it's getting more and more difficult to find water that hasn't got any form of traces. So, I mean, we have one well-known aquifer in Luxembourg that's called the Ice Age aquifer. But every groundwater has little shortcuts, or you have cracks in the rock. So eventually we will start to see traces of human coming through most of the groundwater. We haven't actually had samples from this Ice Age aquifer yet, so we can't say this directly.
Where is it?
This is around Bacharach. The Lourdes water is coming from there. But what we're seeing is over time, when we were first constructing our research in Leipzig, we would all go and try to find the reference site. So we would have this control sample, and it's very difficult to find reference sites now. We're just seeing sites that have different contamination to others. And even in the alpine areas, we're getting a lot of, it's a global cycle, and we're seeing contamination that even starts in America will eventually cycle around the globe, and this can come down in the rainwater, even in some very pristine areas. We're seeing it in Antarctica, we're seeing it in the Arctic, we're seeing it also in Europe as well.
Water in itself is one thing. Does air affect water?
Yes. Yeah. And Europe also went through these episodes of acid rain where the industry or the industrial pollution was basically being rained down then as acid when these events came. So yes, it's not just a water cycle, it's a complete cycle.
So it's highly, highly complex. Yes. But we managed to do quite a lot to sort out that part of acid rain. So hopefully there will be some positives in this story. As we've mentioned a couple of times, water doesn't follow national borders. So for a country like Luxembourg, it's sitting downstream of its neighbours. We're at the mercy of many other conduits. When you look at Europe as a patchwork of countries, how is that affecting water, and how water is treated differently in different countries?
It's true, it's treated differently in different countries, but we also have European regulation. Of course, Switzerland is a little bit outside, and there are source waters. But within the European regulation, we have something that's called priority pollutants, which we're looking at across all of Europe. And then they define what's called river basin-specific pollutants. So it's not pollutants for a certain country, but rather for the different river basins, so that then for these certain rivers, we can follow pollutants that are of concern. So these are actually on monitoring lists and regularly monitored. And every country in the EU has the obligation to do this monitoring and report these results to the EU. And then also within Europe, we are a network of researchers as well, doing exactly the research that we're doing, looking at what's also not just on those lists, but what might maybe need to be on those lists, or what could be up and coming that we have to deal with. And I know you said we wouldn't go too much into the mass spectrometry, but this is also...
I'm happy to go into mass spectrometry. I just want to keep the listeners with us.
Yes, but this is the way we do the detective work in a way, so we can detect the chemicals and basically go upstream. So if we find something we're worried about, you can actually trace this back further along and see where the source is coming from. And this has actually been happening in Europe, and especially also in Switzerland for a very long time. So they had the big disaster in 1986 in Switzerland where the Rhine was extremely polluted. So they said the Rhine was running red and all the fish were dead. This actually instigated a daily monitoring of the Rhine River. And once the high-resolution mass spectrometry technology became more routinely available, which actually only happened in the last couple of decades, they've actually been doing routine daily monitoring, non-targeted analysis in Basel every day to see what's going through. And then you can actually give a warning to Stuttgart before Stuttgart will get a problem and withdraw its drinking water, and so on and so on.
And what was the cause of that in 1986?
This was an industrial accident. So it was, It
was a known accident at the time. Well, this is the concern of a citizen who turns on their tap for that point of drinking water. As part of the public, we hear about water contamination, we think about pollutants, we might think about pesticides, but that's only a tiny part of the picture. So when you are thinking about water and you think about the word water contamination, what comes into your mind?
I was going to say we try to look at them all. So you already mentioned quite a few of the contaminants. I mean, in the end, pesticides do get a lot of focus, but the reality is we're also quite a populous, okay, in terms of numbers, we're not a hugely populous nation, but we are quite a densely populated area close to the city and also in the south. So we also see a lot of human signature in the water that we see. So a lot of pharmaceuticals, and you mentioned it in the introduction. We can see cosmetics, we can see what people are wearing, we can see the medication that they're taking. You can see sometimes what clothes they're wearing, because these will also have different dyes. We can see the flame retardants, and I remember we had this discussion about the flame retardant. It's looking at house dust, not water, but you can also see the differences in regulations between different countries on the different signatures that you see in the water. And we can also do comparison with, for instance, America. We will see different pesticides in American waters versus European waters. So yeah, for us, it's a big fingerprint that tells you a lot about life in a way.
It's huge. It's also scary when you list things like that. So let's take them one by one. So pesticides, everybody would think, okay, we really need to extract them from our drinking water. Is that managed?
So our drinking water is treated. So there are filtering, it's also monitored. So they're doing routine monitoring on it to make sure that it is in a good state for us to drink. And we actually didn't get to that yet, but there's also a lot of not just chemical testing going on, but usually effect testing as well. So you can see if there's any unexpected toxicity in the water. So even if we can't identify a chemical. So it's a lot of the treatment is aimed at getting concentrations below a level of concern. Total removal would actually...
Okay, stop there. Yeah. Below a level of concern.
Yes.
Now, this is a great line. Exactly. How is that line drawn?
It's a very difficult line to draw, and it's one that the public really struggle with. I actually, when I was still in Perth, worked on a contaminated site where they drew the level of concern at 1 in a million. And the public were like, but Perth is a city of 1.5 million. That means at least one person is going to die. This is not acceptable. Which is a valid point, but on the other hand, cleaning that site up to the next level was pretty much impossible.
Yeah, actually, just
the expense and the our resources that we have to do this, within the technology to do this. So it's something that's very, very hard to communicate to people. And it was also not that 1 million people were exposed to this one tiny site. And so then this is also one of our challenges as environmental engineers, because you mentioned I have both backgrounds. How can we protect people from that contamination? Can you just prevent them from accessing it so that there is no risk? Or do you treat, like we do with the drinking water, you treat it to get rid of the risk?
You've also mentioned the fact that cost comes into this, yes, of course, as well, because it's public money, effectively, which will be cleaning the drinking water. So pesticides, okay, they seem to be monitored more or less. But just when you mentioned Perth as well, I just want to bring into the fact the conversation. I remember you saying that living in Perth, the water had to be treated to a higher temperature to get rid of bugs and various microbes there, compared to the level of temperature treatment in Luxembourg, because up until now we haven't had the same climate as Perth. So just talk to us about temperature treatment of water.
Yeah. So this is really important, because the Luxembourg, our water supply is around about 10 degrees. Which is also why when you turn on the tap, if you want to be sure that your water is not coming through the pipework in your house, let it run for a bit. When it runs cold, this is what they basically say. This is then the water that's being directly supplied. It hasn't been sitting in your pipes. And this is really important from a microbial perspective, because the treatment is not just to remove chemicals, it's also to remove microbes. And this is where there's a lot of concern about the chemicals, whereas where actually the water is being treated to prevent us from getting microbial diseases, which we've seen in Africa now with Ebola. You see a lot of these things. We don't have these problems here because our water is treated. And at 10 degrees supply, this means you can actually... The disinfection is very low that you have to do. When you're growing up in Perth, which is what I did, the water can easily get above 27 degrees in the supply chain. This means we have to put a lot more disinfectants in so that we have no microbial growth that won't actually give like a routine poisoning of the population, basically. So this means our water tasted bad. And I was in Spain last week. The water also, you notice it tastes quite a bit worse than it does in Luxembourg. This is, again, the treatment, because it's much warmer water. And you have to make sure that you're not actually supplying a microbial problem to the community.
So just as an aside there, you mentioned something very, very important for anybody, which is that we have to let our water run. And I think it's for around about 2 minutes. And then our water at least here in Luxembourg, but perhaps beyond Luxembourg's borders as well, that should run it so that it has to be in the sitting water in our pipes.
Yes. Although these days with drought, I would recommend you run your water into a watering can and at least put that water on your garden afterwards, because your garden will not complain.
Yeah.
And it will certainly be happy about the water now. So this is basically what we do every morning. Let the taps run, collect it in a watering can, and then this is what's going on the garden. But yes, it's quite important because for older houses, and I don't know terribly much about it in Luxembourg, but for older houses you can still have things, at least in England, with lead piping and some of the really old pipework. With some of the slightly newer houses, but not very new, you can have some of the plastic piping. Some of those plastics have, in the meantime, been phased out. Some of them are that we're having new plastics phased in where we think it's not a problem, but we're beginning to see results that, from our point of view, indicate that some of these newer plastics might be as much of a problem as the one that was phased out. So yes, we would definitely recommend at least rinsing through, so that you're not drinking. If you have any strange taste, rinse it through, because the water that is actually being distributed to you is very good quality.
And so what is the best piping to have in your house? For any plumbers listening.
I was going to say this, I would not be able to say. I don't know enough about the supply
I think we
yet.
don't actually know yet is the answer.
No.
You mentioned the UK, you mentioned England and various rules there compared to Europe, the EU I should say. Flame retardants. This is something that really surprised me, because I know the regulation in the UK is very strong on buying flame retardant furniture because there was some terrible accidents there. So we understand why those laws are in place. And weirdly, actually, in mainland Europe, the laws on flame retardants are not as stringent as they are in the UK. And you can see this in the water.
Oh, we can see this in the dust, at least. From the water, I don't have a direct comparison. But yes, we indeed saw much larger signatures of flame retardants in the UK versus EU. And you can also see differences in the flame retardants that are being allowed. What we are seeing is we do see the flame retardants even in the water here. So this is one of a very good example of this terrible problem we're caught in, right? Nobody wants a horrible fire event, and I guess we can all see what's happening. Of course, it's outside, but still, you can see what's happening in France. You can see what's happening in Spain. We've all seen the horrible footage of what happened in the UK as well, with this building that went up in flames, and it really spread throughout the entire building extremely quickly. On the other hand, having them everywhere means we will then be exposed to them everywhere. And then this is the downside, that we will start to see these signatures in the water. And then at some point, yes, these will have to be treated.
Yeah. And of course, what we're not saying is, of course, if the signatures in the water, they're going into our body, and we don't quite know all of the effects of that too. Yeah. Adding on to that, we also have anti-icing agents. We have disinfectants. We have dyes from our clothes, from hair probably as well, and cosmetics.
Yes. Yeah, it's...
so what should we do?
Yeah, it's a really difficult challenge, right? And I mean, the anti-icing, it's clear. Nobody wants to slide on the road when it's frozen, so we need them. For some things, there's a lot of research now going into these so-called replacement products. So if there's a chemical of concern that we need to replace,